Right. In this section of film, we're going to take a look at a skill referred to as scientific notation, which is really simply an easier way to write numbers that are very, very big or very, very small. In scientific notation, what you have is you have a number portion that usually involves the use of a decimal. In this case, it's 1.2. And then you have a times 10 to an exponent, um, which is the exponential portion of the two. Now, when you use a calculator, the way this number would be displayed is 1.2e minus 10. What that simply means is the e says 10 to the power of minus 10. Now, what we're asking you to do when you actually do this is to not use the e, but simply write it as a scientific notation as we know it. Now, what happens in scientific notation is you take an actual number itself. In this case, it's 5983, and you move the decimal point until it's the right side of the last number, I should say the first number. So it becomes 5.983. Well, 5.983 is a much smaller number than the original number, which is 5983. And the result is, therefore, you must multiply it times 10 to the third. And it's 10 to the third because you moved it 3 decimals to the left. The way to remember that, if you will, is that if the number itself gets smaller, then the exponent has become a bigger number to compensate. And the number down below is 0.00034. Then what happens, you simply move it to the right to get 3.4. Notice that 3.4 is a bigger number than the 0.00034, and therefore you have to knock it down a notch and make it times 10 to the minus fourth. Now, to make these conversions, we're just going to move the decimals back and forth. In the chemistry that you'll do, we actually won't move numbers too much to scientific notation or back again, but this does give you an idea about how these numbers work. So 8.96 becomes 89,600. So you'll notice we move the decimal to the right 5 times to get rid of the times 10 to the fifth. In this case, what we're going to do is take the number and make it times 10 minus fourth. As you might suspect, we move it to the left 4 times to get the decimal. Now, if you want to again make a conversion, 562 becomes 5.62 times 10 to the minus second. Now, at this point, I want to make an interesting or important idea. When you give a number in scientific notation, you are always going to give it as a number, the last number, followed by the decimal point. So you'll notice here you get 5.62 times 10 to the second. Well, why not convert it to 56.2 times 10 to the first? And the answer is you could do that, and that is an accurate answer. But when you put numbers into scientific notation, the first number is the number that the decimal goes after, followed by all the other numbers. And we'll again show here we want to move it so that the 3 is the lead number followed by the decimal, and that means you get this times 10 to the minus third. Now, one of the powerful things about scientific notation is it allows for the computation of very large numbers to be much simple. Now, in this case, you have the addition of two numbers, 8.96 times 10 to the fifth and 4.21 times 10 to the fourth. Now, to add those up, what you have to do is you have to match up the exponents. So notice we have to convert the bottom number to a 0.421 times 10 to the fifth, since the 10 to the fifth exponent is what must line up. When you do that, you simply add the two numbers together and carry down the same exponent, giving us a 9.381 times 10 to the fifth. Now, what about multiplication? This is where the power of scientific notation comes in. What you have here is you have 5.0 times 10 to the third multiplied by a number 2.5 times 10 to the fourth. So what you do is you divide the problem into two parts. The first part is simply going to be to take the exponents and add them up. So it gives you a 10 to the 7th. Now what you do is you simply multiply the 5 and the 2.5, and it gives you a 12.5. So notice there's two events going on. Now we need to convert the 12.5 to true scientific notation, which means that you'll move it over one more and make it 1.25 times 10 to the 8th. Take home message: when you multiply exponents, you simply add them up. Now here I have a division going on, and here you've got a 8.2 times 10 to the 3rd divided by 2.0 times 10 to the minus 7th. Now when you have a division, what you do is you subtract them. So 3 minus a minus 7, it's the same as 3 plus the 7, and therefore the exponent was going to be 10 to the 10th. Then what you do is you take the other side of the equation, which is 8.2 divided by 2, and you get a 4.1. And that's already in the proper scientific notation. Now what I'd like to do is work out some problems here. And to do that, we're going to use a art program. So what's going to happen here is I'm going to import a set of problems and take a look how to solve those. Let me get this right here. Sorry. I'm having a problem. Come on, Mike, you can do this. There we go. I'll pause it and import. Right. So let's take a look at this problem we see here. It's when 1.92 times 10 to the minus 6 kilograms is divided by 6.8, and the little hash mark actually is times 10 to the 2nd milliliters. What does the kilograms over milliliter become? Answer is this. Let's write the problem out. So you've got, we got to get our writing utensil going here. See if I can get this right. Maybe not. We'll find out. So we've got 1.92, and let's see if the problem is here. Let's try that. There we go. You got 1.92 times 10 to the negative 6th kilograms. And that's going to be divided by 6.8 times 10 to the 2nd milliliters. Now what we're going to do is divide the problem into two parts. There is this part, and there is this part. So what we do is you take the minus 6th minus 2, which gives you 10 to the 8th, and you take 1.92 divided by 6.8, and you get a 0.28. And of course the units are going to be kilograms per milliliter. Now we can't stop there, because you'll notice that this is not in true scientific notation. So we then have to convert it to become 2.8 times 10 to the minus 9th kilograms per milliliter. Now that becomes the problem's answer. Now again, perhaps you can start to see the big advantage, whereas this calculation can be a bit troublesome. However, by breaking it into two parts to solve it, we see it's actually rather straightforward. Now what I'm going to do is solve another one. Let me see if I can get out of this one better than last time. All right. Right. Here's a new problem. When 6.02 times 10 to the 23rd is multiplied by 9.1 times 10 to the minus 31, what is the product? Now, I prefer to write these problems out in the following manner. You would write, oops, I got to again convert to my writing format. Let's see if I got it this time. See if I got it now. Fantastic. So I got 6.02 times 10 to the 23rd. Now here's the way I'm going to write it out. I'm going to put parentheses here because that's an actual number. And what I'm going to do is I'm going to multiply it by 9.1 times 10 to the minus 31. Now, like we saw with division, we're going to divide this problem into two parts. The first part is I'm going to work with the 6.02. I'm going to multiply it with the 9.1. So I'm going to work with this right there. And it's going to come out to be, when I multiply those two numbers, I get a 55. Now, when I work with the other number, these right here, I have to add up my exponents here. And when I add those exponents up, it's going to give me a times 10 to the minus 8. But once again, I'm not quite there yet. I've got to convert 55 to a 5.5. That means I've got to change my exponent to a minus 7. Now I'm in business. Fantastic. I've got my answer. So take home message. When you're multiplying in scientific notation, what you do is you take the two numbers of the two areas, you multiply them, and you take the two exponents and you add them together. And then you change it to the scientific notation itself.